Greetings, math people. So this video is for students about to enter their first year of calculus in the fall. So whether they're taking Calculus 1 in college or AP Calculus in high school, we're going to be going over things that you need to understand that were covered in prior math courses to help you be successful in calculus. And so in this particular video, we're tackling the natural log and its application. So let's go ahead and get right into it.
Specialize in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section, vocal toe-to-toe, impeccable, splitting your back, son, simple as addition and subtraction, black thought, the infinite relax one.
All right, so the natural log is a log of base e, and you should have covered logarithms in Algebra 2 and in pre-calculus. So we're going to do a quick review of what a logarithm actually is, and then look at the natural log and some of the properties of the natural log that we find important to utilize in calculus. So what I'm going to do is write an exponential expression here, and I'm going to write 8 cubed is 512. And I'm pretty sure everyone knows what that exponential function means, the exponential expression means. And what I'm going to do is I'm going to write it in logarithmic form, which will be the log base 8 of 512 equals 3. And just to juxtapose this to give you a better understanding of logarithms. So you know what 8 cubed means. It means you multiply 8 times itself 3 times and you get 512. And the logarithm is kind of the inverse of an exponential form. And what a logarithm does is a logarithm finds exponents. So for instance, when I'm saying log base 8 of 512, the question I'm asking is what exponent do I raise 8 to in order to find 512? So again, a logarithm finds exponents. So a log base e, so let me just say log base e of say y. A log base e is written as ln. Now, coincidentally, when you get to more advanced levels of mathematics, you know that this is called the natural log. You will see it written as like this in more advanced math books. When you know this generally in like the stuff you'll see in high school, that's a common log, a log of base 10. But in some more advanced math books, they will write log, just regular log, for a log of base e. So just something you may see. But let's talk about what we need to know about this natural log, how it pops up in some calculus problems, etc. So I want to first look at a couple of important natural log values. For instance, ln1. So ln1 is something you should definitely know what it equals. Now, if you think about it, again, ln is a log of base e. So this is basically saying, again, a logarithm finds exponents. So this is saying, what power do I have to raise e to in order to get 1? And that, of course, should be 0. Because anything to the power of 0 is 1, except, of course, 0. So ln1 is 0. Another one that's important to know is ln e. So again, it's saying what power do you raise e to in order to get e? That would be, of course, 1. So ln e is 1. Another one will be like ln e to the k, if you will. And what that's saying is what power do I raise e to in order to get e to the power of k? Well, that should quite instantly be k. All right, so all three of these are a pretty significant importance in the calculus scheme. I want to do some sample problems on this last guy. So what would happen? So there's a problem in calculus. It's called a differential equation, and what you'll see, at least initially, will be what is called a separable differential equation. And what will happen? I'm not going to get into differential equations here. Here we're concentrating on pre-calculus concepts that you're going to need in calculus. But what will happen is you'll get an expression where you'll get something like e to the y equals some expression, some stuff. For instance, say it equals x cubed plus 2x plus 4. And you want to solve this for y. You want to pull it in y equals form. Well, if you understand this, if I know that ln e to the k equals k, and I want to put this in y equals form, what I would do is take the ln of both sides. I would take the ln of e to the y and also the ln of the stuff on the right. And again, since ln e to the k is k, ln e to the y is y, and y would equal that stuff. And pretty much the problem is done. You couldn't take independent natural logs of these. Like it wouldn't be like ln x cubed plus ln 2x plus ln 4. You couldn't do anything like that. So this expression is pretty much finished, and that would be the answer. All right, so let's also look at another thing that occurs in a similar type of problem, these differential equations. Another thing that would occur is that you would get ln y, normally y would be an absolute value sign, but I'm just going to say ln y equals some expression, say x cubed plus 5x plus ln 2. I'll say something like that. And it's the same deal. You want to put it in y equals form. So you have to think about, what do I have to do to this to get the y, by itself? Now, of course, you can't divide both sides by ln. Ln is an operation. It's not something that you can divide by. It's like, like trying to divide by cosine. Cosine is operation acting on something. So you can't divide by it. But just like with cosine, you would take its inverse, which would be arc cosine. If I had like cosine y equals something, I wanted it to be y, I would take the arc cosine of both sides. Similarly, you can do the inverse of ln y, which is inverse of ln, which is e. You would exponentiate both sides. So how it looks is you would say e to the power of ln y, and that would equal e to the power of all this junk here. Now, so what's e to the power of ln y? So let's think about ln y. Now, again, a logarithm finds exponents. So what ln y equals the exponent that I raise e to in order to get y. That's what ln y equals. So whatever it is, so let's just say ln y equals some symbol. It equals asterisk. Okay, ln y equals asterisk. What asterisk does means that e to the power of asterisk is y, right? So ln y is what I raise e to in order to get y. So if I have e to the ln y, again, ln y is what I raise e to in order to get y. So e to the ln y is simply going to be y. And now this stuff, this is not always just left like this, so different from the previous problem, because based off the properties of exponents, I can write this as e to the power of x cubed times e to the power of 5x times e to the power of ln 2. And really the only reason to write it like that is because of this. So again, just by what we said, we just said e to the ln y is y. Well, e to the ln 2 is 2. So this could be y equals 2e to the x cubed plus 5x. So a last little principle to give you is that e to the ln anything is anything. All right. So that's really all you need to know about the natural log in terms of its pre-calculus, what you learned in pre-calculus to be beneficial in your first year of calculus. Hope you enjoyed the video. See you next time.
Specialize in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section, vocal toe-to-toe, impeccable, splitting your back, son, simple as addition and subtraction, black thought, the infinite relax one.